Sounded very dangerous. I did have a really exciting, I think really exciting. We'll find out at the end of the month. I took a big risk while I was there. So several of you I've talked to outside of class know I'm kind of into like these mining Bitcoins and stuff like that, right? Well, so I ended up sending about $7,000 in Bitcoins to some random dude in China in hopes that he delivers a product to me at the end of May. It's a Bitcoin mining computer, like a super high-powered one. If he delivers it, it'll be a really good investment. If he doesn't, that's $7,000 in Bitcoins that literally just disappeared. Because there's no way to get them back. It's decentralized currencies. There isn't like somebody to complain to. I'm actually creating a business with a couple of other people around this concept of, we're going to give a presentation here on campus at some point, probably early next semester. And we might do some conferences over the summer, but Bitcoins are really cool, but they're kind of like the Wild West. It's good that they're decentralized, so governments can't just say we're going to print more money, but it's bad that they're decentralized because nobody's in charge. Nobody can say, hey, you screwed this guy over. give him his money back. So, I don't know, we have a couple of interesting computer science-y solutions to hopefully protecting some of those transactions. But, so I'll either get a really cool product or I spent $7,000 on marketing proving that I've been scammed, which is why they need our business, right? Let's look at it that way, I guess. That was the exciting thing I did at lunch one of the days at Chicks. Is I'm sitting there and I had 15 Bitcoins in the wallet and I had to send it to, this random hash address, for the guy on the other end. Here's, show it to you real quick. Here it is. Thank you for your order. They received. I must send my Bitcoin payment of 15 to this unique address within 1 hour, which is pretty common for Bitcoins. As soon as my payment is received in full, I'll receive an email confirmation. I have not gotten that yet. It's a little concerning.
More than an hour, your order was canceled.
Huh?
It's more than an hour now, your order's canceled.
No, they definitely got it. I can prove they got it. Yeah, I have, I think this is I have the screenshot.
Oh, that was sketchy. Pretty high. I don't know if I can get that one.
No, I got a screenshot somewhere. You can prove the transaction went through. That's one of the benefits of Bitcoin, is that the blockchain is searchable. So I can see that something left my wallet and went to that wallet. Boom. That doesn't mean I don't know who that owns that wallet.
Right. But it's there.
Nor can you do anything about it.
Right. I can just prove he got it. Yeah, it's the equivalent of I sent an envelope filled with cash to somebody via the post office, and I don't have to worry about the post office didn't deliver it. It was delivered. But at that point, he could just keep my cash and not do anything. So it's the same problem. So we'll see. It'll be interesting.
Indeed.
I mean, surely a random guy named Fang from Hong Kong is trustworthy, right?
Could be.
Sounds legit.
We'll find out.
It's too late now. It's nothing I can do. It was too late 2 seconds after I did it. So might as well stay positive. All right, so we have to work on our EMP Blast. The control. Oh, there we go. All right. So, with the EMP Blast, we probably want to, only let them do it so often, right? But B, it has to look a whole lot cooler than
A big square.
a big white square, right? So they shouldn't be able to just spam EMP Blast. But at the same time, I think there might be some advantage to, because right now, let me turn the volume down a little bit. We don't want him to get too out of control. So what happened up here? You getting a fist fight?
No, I fell.
Fell down a flight of stairs?
No.
Just fell.
Yeah, on an obstacle course. Stomp the yard thing.
Is that a thing Friday?
Yeah.
Yeah.
I
Friday.
wanted to go to that, but I was in.
Did you finish, or was that like a loose consciousness thing?
No, I
Is
just
there actually a mechanical
rub
bull?
against the inflatable thing and it just.
Oh, it's like a rug burn type
Yeah.
thing. I got you. It looks worse than it is.
They
Yeah.
had a mechanical bolt too.
I
Yeah?
wanted to get on it.
Did you ride the bull?
No.
I would have if I was here.
All right, so right now, when we fire this thing, it hits everything in its path. I think what might be cool is if we had it kind of create. We did something with particles last time a little bit, but if we created kind of a instead of a single EMP, it's almost like we shot out a bunch of like a kind of a wave of drones, if you will, that kind of goes away from us and kind of swooshes out and it just hits what it hits and hope for the best, right? So it's not necessarily something we need because right now we're just creating a big old swath. So I'm kind of thinking, how many of you have seen the movie Independence Day? Great movie, right?
Finally, when we
It was a good movie.
It's okay.
It was better than okay.
Yeah.
Independence Day was better than okay.
They could have done a better job.
honest trailers will ruin anything for you.
Oh, of do what? Of hacking the mothership?
Yeah, when he hacked the mothership when they were inside.
Did you notice they used a Mac?
Yeah, I did actually. That was good.
The book was actually pretty good too. There was a second book that was the same time frame, the same storyline, but from a different perspective. And you actually see in the movie the one scene related to the story of the second book. If you remember the movie, when the Americans start sending Morse code to say they're going to organizing an offensive or whatever, and it's got like dudes in Israel. The second book is the whole Israel story. You know, where the ship is there, and bad things are happening, and the aliens actually came down and were running around shooting people. Far more entertaining in Israel. Yeah, it was actually a pretty good book. So the one connecting point between the movie and the second book was that scene that lasted like, I don't know, 14 seconds or something.
Yeah, bro.
Tops, 14 seconds tops. Well, the reason I asked how many of you have seen that is if you remember when the first fight started between the Americans and the mothership, not the mothership, the ship.
Right.
Ship thing. They started releasing their little alien ship drone thing. They look like a bunch of bugs flying all over the place, right? So similar to our little spinning heads here. So I'm thinking what we do is we literally release our own attack squad and let them fall towards the earth, kind of at different, fall towards the Ewoks, I guess. In fact, we might even say they could hit the Ewoks. I mean, why not? It's a weapon, right? So more of a scatter shot type thing. Okay, so how would we implement this? Let's start this with little boxes. So we'll go back. We have our one EMP, right? We call it EMP. So we have our one EMP. Right now it's this huge thing. Let's go ahead and make it a lot smaller. So let's call it 5 by 5. The Nexus Wave from Star Trek?
Yeah, have it grow as it comes out and just destroy everything in its path.
Maybe at a later level. That'll be our EMP. We can upgrade. Every level we can give points. Okay, there we go. Oh, come on. I think I need to pick a different button.
Yeah.
Like enter.
Can't use command. Yeah, I think I can use option. Let's go back to this. Where's my, oh. Is my EMP not in this guy?
Might be.
Oh, here we go.
Yep.
Yeah, here's my EMP. EMP Blast. That's Alt. Yeah, that'll work. Option. We're going to change it to Alt now. So this guy only knows how to attack the Rickroll heads. Which kind of makes it kind of fun. You have to decide whether you're shooting Rickroll heads or shooting Ewoks. Okay, but we want to create a interesting thing with our EMP where we want to spawn a bunch of them and then have them kind of swoop down, kind of clearing a swath, but not necessarily guaranteeing that it'll hit everything. Okay, so kind of a caltrop type of thing. So
Buckshot and shotgun.
right. So here in our EMP Blast right now, when we hit the Alt key, a single guy is spawned. Well, we might want to spawn a whole bunch of these guys, right? Well, how do we do something more than once?
Time.
With timer. Okay, so we need to drop a timer in here. And inside that timer is where we're going to actually spawn these guys. And let's do it every 0.01 seconds.
Now, are we gonna have a time limit so that it just
Probably.
stops?
Yeah, but let's just see what it looks like first. Yeah, right now, once you hit it once, except right now they'll just show up as just
going straight down.
yeah, it'll be a single stream, right? Oh, actually, it did it for as long as I held the button.
Ah.
All right. But we want to hit it once and have it do something. So let's throw this whole. Well, actually, let's just leave it alone for right now. I don't want to overcomplicate it. But what we want to do is when we run this, we don't want it to just come out in a single stream like that. We want it to, if I'm sitting here in the center, we want it to kind of spread out away from us. So how would we do that? Right now, my guy in the middle, let's just say he's spawning 30 of these. Okay, he's spawning 30 of them. I want those 30 to fall towards the ground, but kind of go wherever, not necessarily go straight down. How would I do that?
Randomize the direction.
Okay. Excuse me. So down here, when I spawn them, I'm spawning them in a certain direction relative to me. I'm going to go ahead and I'm going to say let's spawn it to the right. Let's just see what the difference is. Okay, so everything spawns to the right. Yep. So everything right now, when I have it spawning to the right, doesn't matter because it's just spawning at my center point for the ship to the right of that. So it makes no difference. So we can leave that, doesn't matter. So you want to go to our EMP ammo, right? Okay. So here's our EMP ammo. What do you want to change here?
Maybe you could just accelerate it in like a
Random direction?
between two.
Okay. So it's already going to have acceleration downwards from gravity. So what we really want to do is we want to give it like a, kind of a maybe 45 degree. Let's start with that. So we're going to say that this guy so we want it to go between probably 220 and 320.
Yeah.
Okay, and we'll leave our acceleration at 100 for right now. They seem to all be going in the same direction.
Would it be affected by the direction that they spawn on the actor now that they're accelerating in a different direction?
They shouldn't.
Does it only randomize it once though?
It should randomize it once per guy spawned.
Yeah.
So they should be different values. Let me up the acceleration. So maybe right now they might not be moving out far enough to make a big difference because gravity's taking over too much. So 3,000. Nothing's ever spray shot, so I think we actually. Yeah. I think we maybe need to have it pointed to the right for where it spawns. So let's just make sure this looks better for the. We'll say that looks at least reasonable. Go into our player. So we'll have it spawn to the right now.
That's better.
Why is this?
Yeah, the third one wasn't spawning.
What was happening?
The third one, third guy in the bottom wasn't spawning.
Third Ewok?
Yeah.
Yeah, we must be killing the timer too much.
Whoa.
It's like Legend of Zelda. He was like powering up. There we go. That is actually kind of weird. My guess is that there's only so many threads that can be created, and because we have this timer, all right, we're gonna do this. We're gonna do this differently than this timer, because every single time through this timer, when we spawn something, something's happening. We're going to move the spawn actor out of there. We're going to get rid of the timer. So this guy will spawn one actor. So right now we're back to boring. Okay. Now, whoop. So let's go back into our EMP. We want this guy to spawn more EMPs. So if we have our EMP each spawn, let's say 3 EMPs. Okay, that'll work. So every EMP that is born will spawn 3 additional EMPs.
All right.
What's going to happen with that? So initially I pushed the button for my EMP Blast. EMP spawns a single. The EMP Blast spawns a single EMP. That guy exists, then he spawns 3 more. What do each of those 3 do? Spawns 3 more. What do each of those 3 do?
3 more.
Okay. When does it stop?
It doesn't.
It doesn't. So I'm going to save. because I'm not sure what exactly this is going to do to Game Salad. Yep, so we just did a denial of service attack on the entire game. But we did shut down the Ewoks.
And spinning ball.
And a spinning wall of death, because this guy's taking it. I did save first, so this was expected.
Infinite loop.
All right, so. Yeah, seriously. I should be like on level 40 right now. Oh, I got multiple things not responding. All right.
Well,
So we created the effect of an infinite loop. Ooh, do we want to install this update?
Yes, we do. I installed it.
So this actually introduces something new for us. Another programming concept. And here, while this is installing, I'll talk about this programming concept. It's Pucopotamus. That was a quiz from another class. 200. Okay. So we have another programming concept called recursion. Now, did I mention this before?
you may have.
Anybody remember recursion? Okay. So I'm going to give the definition in terms of Java first. Then we'll talk about how Game Salad mimics this. We just saw it. It doesn't mimic it well. But it actually mimics it similarly unwell. Not wellish. Not wellish. Totally sounds wrong, but totally sounds awesome. So here's the idea. Recursion, in terms of a high-level, object-oriented domain or general-purpose programming language like Java, is when a function calls itself. Okay, that's recursion. Now, to give you a quick example in Java of this happening, similarly to what's happening to us in Game Salad, I'll pop over here to Java real quick. I'll just do it inside of this guy. Yeah, we're building a cave crawler in our Java class, and today we're adding, well, no, tomorrow we're adding in vampires and werewolves, as well as a traveling wood chipper. You never know when you enter a room in the cave to collect your treasure when there's a wood chipper there. I'm just saying. So, as a quick example, I'm going to create a static void blah. Well, here we'll even be we'll be nice about this. We'll call it EMP. And right now, here, this is the program version of our EMP. Every time we create an EMP, what do? We create 3 more EMPs. We call EMP 3 more times, right? And then we initially spawn our EMP up here. All right, so here's our current version of EMP. This is the Java version of this, so I'll call it once. I'll spawn it once here. It'll call this method EMP, and what will this guy do? He'll call EMP 3 more times, and each one of those will call it 3 more times. And Java is going to have an exception pretty quick. It's going to have a stack overflow exception. It's going to say, I've run out of space. Game Salad didn't quite do that for us, okay? The reason it's a stack overflow exception is every single time we make a call to EMP, we have to put this version of EMP on hold. So what we do is we package it up in like a to-go box and throw it on top of the stack. Every programming language is governed by a stack. And we'll come back to it later to finish it. Okay? So we package the first guy up in a to-go box, put it up here. Each one of these three then gets called. Each one of those three gets packaged into a to-go box. We keep putting stuff on the stack, putting stuff on the stack. Eventually we run out of stack space. That's why it's screaming. Okay? So that's the Java equivalent of a recursive call. That is a method, EMP, a function, that calls itself from within itself. Okay? And we'll deal with that a lot next semester. All right. I think it was supposed to relaunch, so let me relaunch it.
Not just do this.
Was there even another version? I think I should just sit on this screen for a second.
Yeah.
Okay, so now our problem in Game Salad is that every single time we spawn off a new actor, what happens? Well, a brand new element is now created that the scene is in charge of managing, right? For every one of those, 3 new ones are created. For every one of those, 3 new ones are created. The scene is getting inundated with new actors to the point where the scene can no longer function. Here, there's our install and relaunch button. That's what we didn't do last time. Perfect. Okay. Back to our initial scene. So, that's what's happening right now. We're inundating our scene. Now, what happens if I switch this down to just 1? Scene will still get inundated, just maybe a little bit less quickly, but still quick, right? How do we fix this problem? Go ahead.
Put that on timer, maybe?
Okay.
Put that,
Which part on a timer?
let's spawn another actor. So if you do it like
Okay.
Every 0.03 seconds or something like that.
Why don't we start it with 1 second,
Yeah.
just so we can kind of see it happen. So we're going to say every 1 second, spawn another EMP. And that EMP will spawn another EMP every 1 second. I'll go ahead and save. Oh, he's being destroyed too quickly. So I do need to make it less than the...
Well, it's getting off the screen faster than that, too.
Right, which then takes it out of the scene.
Maybe we could do it 4 instead of every. Every time you press it, we'll do that 4.
And there it is.
This might survive. I'm going to give this a 50-50 shot at surviving.
Hey!
Yeah.
Okay.
All right, so you want to do this. Well, if you're going to do a 4, then you have to have another timer inside of it. If you're going to do it that way.
Yeah.
Now, what we can do is we can have this guy spawn a new one every 0.01 seconds. How long should we let one of these last? How long should they live for?
Until like half a second. That's enough to get it past the screen.
Well, we can create a timer that says after 0.02 seconds,
Destroy.
let's just say, have it destroy itself. Now, one thing we want to start seeing here is how recursion works. Recursion is considered to be elegant, yet inefficient. So, I mean, the elegance of this is how are we creating lots and lots of EMP actors? we're asking each EMP actor to generate more EMP actors. That make sense? They're replicating like bunnies. Okay? So now what we're going to do is we're going to give a death timer to this, where every 0.2 seconds, this one of these guys dies. And we're actually going to change this to just 0.1. Let's try it for a 0.1 timer there. So this is spawn EMP. This is suicide. Okay. Well, did I put that in the right guy?
Yeah, that's an EMP.
So
New update,
somehow our EMP blast actually killed off our actor, killed off our player.
This is when you tell them that their update failed.
Well, we don't know. We didn't try this beforehand. Okay. Well, in any case, we can have a EMP spawn off another EMP. So let's take this out of a timer. So every single time an EMP is born, it will accelerate in a random direction, and it will spawn off another EMP. But every EMP dies after 0.2 seconds. Again, we're playing with fire. Okay, this is that balance. Essentially what we're looking at here is something that should probably never happen in a video game. Recursion would be a very poor tool in a video game since so much is happening so quickly. Okay, and we're seeing how much it's shutting things down. So I saved it just in case. So we'll try this. So we're going to accelerate, random direction. Every EMP will spawn off exactly one EMP. But every EMP only lasts for 0.2 seconds. So in that, let's see if we can save it. In that time period, before the first one died, how many EMPs do you think were created?
Quite a few. Yeah, it might come back yet.
All right. Well, we can find out. So what I'm going to do is I'm going to create a global variable associated with our game to be an integer. Num EMP. This guy will start at 0. I'll throw another billboard out here. This particular billboard will always display the text that is our game's EMP, num EMP. How many of those guys have been spawned?
The color.
So now whenever one of these guys has been spawned, we need to update our game's num EMP.
Said it's not movable.
Oh, thank you. Okay. So now we're going to go into our EMP. And let's go ahead and let's take off the suicide for right now. We'll also have him not spawn another actor right now. We'll spawn them elsewhere just to test this first. We're going to change an attribute. we're going to change our games num EMP to be whatever it currently is plus 1. Okay, let's go back to our player now. And just for the sake of argument, we push that button here at the end. Let's just have him spawn, I don't know, 5 of those. So we set him not movable.
Click movable.
Well, did I?
When you clicked it, you set it to movable.
Oh, hold on. It was
Oh,
not
it's
movable
not
by
movable.
default. We made it not movable by default.
Yeah.
That way we wouldn't have this problem. So you actually screwed us up.
Sorry.
All right. So when I run it once, it spawns 6 total EMPs. Seem to work okay, right? Not making recursive calls. That's all linear coding inside of our player. It should be 20, I think. That should be 30. So I can now minimize that so I don't have a zillion things in there. Huh? Yep. This is what we wanted in the first place. But notice that there's no slowdown with this.
Mhm.
Because we're doing it in a linear nature and we're having our player spawn off. I think I'm at 20. I might be at 30. I don't remember anymore. Spawn off a bunch of EMP actors individually. The second we had those EMP actors spawn off their own, we got into this recursive loop that became extremely memory and computationally expensive. Now, does that mean recursion is bad? No. It means recursion is bad for some problems. Okay? It's probably a true statement to say that recursion is always bad for gaming. Because there is a lot going on at once. And anything that you do that is processor intensive, or, well, anything that you do that is unnecessarily processor intensive, or thread intensive, is a bad move. If you are writing a business application that is using 0.0001% of your CPU, use recursion all you want. It's not going to make any difference. Infinite recursion is always bad. So if you're going to have something happen recursively, good example of this would be the factorial problem. So let me come back here to this guy. For instance, factorial. We saw factorial in here, didn't we?
Mhm.
Okay. Do I show you the Java version of it? But did I do it iteratively or did I do it recursively?
I think you showed both.
Okay. Well, I'll show it again real quick. So I'm going to say static int fact int n. If n is equal to 1, return 1. Otherwise, return n times driver.fact of n minus 1. So we'll do 5 factorial here. So 5 factorial is 5 times 4 times 3 times 2 times 1. But you could also say 5 factorial is actually equal to 5 times 4 factorial. 4 factorial is actually equal to 4 times 3 factorial. 3 factorial is actually equal to 3 times 2 factorial. That's that recursive call there. That makes sense? So there's our 5 factorial done recursively. Ran just fine, right? No slowdown because we had a stopping case right here. As soon as n hit 1, just return 1. Stop calling things recursively. Make sense? Okay. So recursion is not innately bad. In fact, in many cases, recursion is, I used the example a few minutes ago, it is quite elegant. A lot of times you can write fairly complex solutions recursively. A good example here, this is from another class. This is from the 300 class, so a class you'll have 2 semesters from now. We are processing some JSON stuff in here for our caves. And so our representation of our cave looks like this. Just a bunch of JSON looking code. So we have something here called parse cave. Parse cave gets the entrance, and the entrance to the cave is called parse room. This is where our first call to parse room happens. So parse room gets called right there, and then here's our parse room. Inside of a room, we have treasures and other rooms, because cave rooms lead to other cave rooms. So every single time we hit a treasure, we process that treasure. Every single time we hit a room, we call parse room. This is calling parse room from within parse room. That's a recursive call. If we were to write this, this problem actually would be, do I want to say impossible? At the very least, extremely difficult and extremely verbose to write iteratively. So this would be an example of a problem that is solved significantly more efficiently using recursion, even though we're using a lot of memory in the background. This stuff only happens in our current application, only happens prior to runtime. Well, prior to user interaction. So this all happens when you first start your program. All this code gets parsed and stuff like that, and ultimately creates a cave. At that point in time, we're not calling recursive calls and stuff like that. Now it's a game that runs. Okay, so this would be an example where recursion is perfectly acceptable. All right. So the lesson there is recursion is another tool in your toolbox. Not always bad, but not always good. But from a game design perspective, since we're messing around with games here, it's probably never a good idea. It's definitely never a good idea, I would say, in something like Game Salad. That is, Game Salad's a great tool for what it is. But we've all seen it runs into its limitations very quickly. If we were writing the same code inside of like the Unreal Engine or something like that, recursion would still be a bad idea, but you wouldn't have one of the Ewoks stop firing. It's meant for significantly higher performance stuff where Game Salad is much more of a user-friendly type thing at the cost of you're probably not writing Xbox games with this. That type of thing. It makes sense? Okay, so what I'm going to do is I'm going to go into our EMP. And I want these guys to accelerate a little more slowly than they are right now. Whoa! What just happened? Because whatever that was awesome. Does it always do that in the first one? Who knows? But I'm going to have it, we're going to have it go 150 to 350. A little bit wider swath. Actually, are we spawning it out to the right?
More so.
Man, why can't we always get that effect? Because that's what we want. In fact, let's think about something here. Okay, so that's... Okay, so we want it to be between 180. No, we'll do 190 to 315. Let's do 190 to 350.
Let's go with that.
350, that'll work.
Yeah, that's a pretty good split.
Yeah, I mean that really looks like an EMP Blast, that first one. So
jump up the acceleration.
Actually, I'm going to jump down the acceleration. Why is that first blast so awesome?
I think you gotta go. There we go.
Yeah, I think that's pretty legit. Okay, so what we'll do, we'll come back next time. We're going to add a limit to how many of those, but we also want to change up our particles to look much more cooler.
Yeah.
Much more coolest. Much more coolest. Much cooler.
More cool.
More bestest. More bestest. That's it. So think about what that should look like.